Hi, welcome to the second video of the Zig series. So this video is mostly about uh, constant variables, arrays, and strings. So we'll just these are the fundamentals and the data types that we need to proceed further. So we'll try to, and they are very simple to understand. We'll try to discover that all of this in a full video. So without any further ado, let's get started. uh, just to print, if you remember, to print to print, we imported the standard library using import statement like this, and we captured it in a const std, and this std we can further use further to call the debug structs and the print functions and all. So what is a const? A const is something that does not change its value, does not change value. So this means that once you assign a value to it, it's never going to change throughout. Like you want it to not change throughout your compilation or throughout your program execution. So that's where you assign those. That's where you introduce const when you know that this thing or this value should not change throughout the course of the execution of the program. So something like let's just create a main function. If we remember, uh, main function is the entry point of it, and let's start with const. So how do you declare a const is you start with the keyword const, and let's name it x, and here you do colon, and then you define the data type. So the data type, there are multiple data types in Zeg, but we'll just explore one by one, very simple one. So we'll start with unsigned integer. So what is an unsigned integer? It's basically positive numbers starting from 0 till whatever is your size. So you define that using u. U stands for unsigned, and then you define the size of the bits. So it's going to be an 8-bit number. So this 8-bit number, that means 2 raised to 8. That is 16, 16, 256, 255. So basically, this is going to be 0 to 255. So this x can take values from 0 to 255. So we can just provide something like 144. And now, since you expect it to be consistent throughout the program, so I want this x to not change. That's why I've assigned as const. So now let me just print. If you remember the print statement. So how I'm gonna print is it's gonna be x. Sorry, x equals to, I'm going to capture this. So this, I want to print the x variable. So what I'm going to do is I'm going to capture it in this open curly braces. And if you remember, we pass an args, right? In this. So in this arg, I'm going to pass x to it. Now, what I'm going to do is I'm going to do a zig build. And yeah, it built successfully. If you see it spit it out as zig out, and if you remember, we are executable as inside zig out slash bin. So here we'll have this executable made on the basically the folder name where our project lies. When we run this, we see x is 144. Now, so we have successfully printed it, and now let's just go to the main.z. And since I mentioned const doesn't change value throughout the execution, if I try to change its value from 144 to 122, look what will happen. So compiler, just look at it. The compiler should throw an error because const should not change value, and we try to mutate it. It's an immutable, but we try to mutate it. So we'll do zig build, and yep, here it is. You can see x equals to 122, errors cannot assign to const. Yep. So now this is done. So let's go and fix this. So this cannot be remove this. This cannot be changed. Now, what if you want to change things because that is required. So you use something called as var. Var is a keyword for variable. Variable in its nature is which can change. Let's just define a variable y equals to, and let's just go with u32, which is for a larger number. And now we'll just do like something like this. Now, if I print this, I'm gonna do is basically I'll uh, print. y here only, and I'm gonna pass y here. These are based on positions. If you see, this bracket comes first, so this capture comes first. So the first argument will, so this x value will be thrown into the first bracket, and the y value will be thrown into the second one. So now, what happens is, what I'm gonna do is I'm gonna modify the y. I'm gonna modify the y to, let's just say 45, and I'm gonna do is print the y again here. And now let's just try building it again. And now we'll go to zig out, then, and now, so, okay, let me add some new lines so that we can see the output clearly. Yeah, let's just again build it. We have to rebuild it again, and then zig out, then, two. Yeah. So do you see the x value remains changed? It's a constant, and we cannot modify it. The y value, we modified it from 2342 32 to 45, and you can clearly see it here. Yeah, so that is a variable for you. Yeah. So if so, the other thing is we can also use a different data type instead of unsigned integer. We can use integers, which is gonna be basically which will lie from a negative end, 0 to positive end. But when you use this, the value is range is half. So here we discussed U8 range is 0 to 255, but it's gonna be here. It's gonna be basically uh, the range is gonna be minus 128 to 0 to 127. If you see, so what happened is it's basically ranging from, instead of from the only from the positive end, we divided by half and put that in the negative end to so that it can cover the negative integer as well. So in this 8 bits, I8, you can assign all these values to it. Awesome. Now, so we have already seen const and also var variable. Now let's get started with arrays. So how do you define an array? Basically, let's just for the beginners. So arrays is basically a list of data type, something like a list of integers, a list of some kind of data type you have in a contiguous memory. That means you can access each element by simply incrementing the pointer to it. So suppose I'm in this index, or I'm in accessing an element, fourth element of the list. So how I can access the next element of that list is I'll just tell it, give me the fifth element. That is, I'm in position 4. I'll increase the position by 1, and I can simply get it. That's why arrays are very powerful, because they are very fast and the ease of access is very quick. So how do you declare an array? So basically, we'll go with the data type. So we can start with either const or var, but once you do a const, you cannot change the array elements because it is immutable. So we'll just go with var. So because if we want to play around with the array, so let's just name it arr. And what we can do is, so arrays declaration start with this. You have an open close. This is indicator of the list, and then you define the type of the elements, data type of the elements going to store. So this array is going to store, let's just say, unsigned 32. That is 32 bits of numbers 0 to u to raise to 32 minus 1. Now you can say something like 1, 2, or some big value. Yeah, this it cannot store negative because the data type we are storing is unsigned. Now, what will happen is you have to tell the basically the compiler to how much memory do you need for this to store this. Since this is U32 and this is gonna store 32, this is gonna store 32-bit numbers. But exactly how many 32-bit numbers do you need? You have to tell the compiler. So here we know it's gonna be 4. So what we're gonna do is we'll write 4. Now that's there. So once this is there, so this is how you basically declare an array. So let's just go with printing. So we can print something like s, and we just say we want to print the second element. So we don't know. So to print this, yeah, obviously we capture it. And to access the elements of the array, right? What we do is we use indexes. So indexes can be of use size, but we'll go look into that in future. But simply, let's just say this is at the moment it's the position of each element, and we start with zero base indexing. That means this one has zero index, two has one index, this so on, this has two, and this has three. So the second element has index one. Basically, what we're gonna do is we're gonna print, do this. The basically array name, and then you have the square brackets, and inside that you pass the index. Once this is there, uh, what you do is uh, is the local variable is never muted. I'll tell you what happens here if you do this. So here, Zig tells you that this array value is never getting changed. So instead of a variable var, use const. So if I just want to print the the current one, right? So what I have to do is basically change this to const. But as mentioned, we are going to play around with the values. So what we'll do is we'll modify this value. To modify it, we'll capture that value. Basically, tell the compiler, oh, whatever this value is, put the right side value. So the array is the second element from 2 to, let's just say we do it this number. This number is gonna get stored into this part in replacing 2. Basically, the first position of the array, it will just replace the value. Now, if I just do this again, see same print statements, we are printing the same values. Now, let's just build this. It will not throw an error. So we'll go to zig out, then we'll do lecture 2. See, the first element was 2 earlier, and now later we mutated it to 32332. The other thing, one more thing is the sizes. So here, if you remember, if you notice, we passed 4. So Zig compiler is smart enough to auto interpret from this key how many number of elements it is, and it can autofill this value. So to do that, what you do is use underscore. So this underscore is basically tells it to self-inference the exact uh, array size that you need, exact number into 32 bits of memory it will need for this to execute, to declare. So this will, if you see, if I does zip print, it should not give me any error. It didn't. So now let's proceed to some array manipulation. So we have this one array, and I'll just copy it here, and we'll call it array 2 basically, and just change the values. Uh, we'll have something like some random numbers. I'm not sure if that can get stored in 32-bit. Yeah, these are the random numbers. Now, what if I just want to join array and array 2 into into a single array? So how do I do that? To do that, what you can do is basically we just define an array 3, which is a combined array. What I'm going to do is I'm going to use a plus plus operator, which is a concatenation operator here. It concatenates, that is, it just plugs in, joins them. It's going to be something like array plus plus array 2. Now, what is happening is it's saying local variable is not muted because we are not to const so that we don't get the error. Now, what we do is I just simply print the combined array, and instead of here, we'll just pass array 3. And here, this is also never muted, so this will be also be const. Otherwise, the compiler will throw like die. Just let's do a zig build. Here, the compiler, you'll notice one error. Here, the compiler will give an error as when, so the compiler can auto infer, like if you are passing any integer or any number, you don't have to define a specifier. But if you are just printing some strings or UTF strings, you have to pass specifier to let it know that, oh, this is of this data type. So now here your arrays you cannot pass directly, you cannot leave it empty. So now to print the array 3, we cannot directly use like directly just leave it empty here. We have to specify its type. So the hacky way to do that is let's just write any. This any will tell it to print all kind of any kind of data type it has. If you do this, zig build successful. Now what I'm gonna do is basically zig out, print, and let's just print lecture 2. You see? So the any is basically gone as the your infer type. It's like any type of data type you do. Well, there is just one more operator where you can just let me just say array 4. So this is this array. If I want to just repeat the same array, I just say 3 times. Basically, it's gonna do something like this one to this element and then again repeat it thrice and insert it in a single array. So now I'll just print this pattern array. We'll just call it a pattern. If it is unused, we'll comment it out because we're not using it. Same example. The compiler really cries if you just leave some unused variables or like just you're not mutating anything and you assign it to a var, the compiler will throw that. So now we'll just go to zig out, then here we'll do this. You see the pattern there? It's basically this pattern repeating across thrice using the multiplier. So that's there. So this that was for array. So let's go to strings. Before strings, let me just clean this up a bit. Yeah. Uh, if you remember, so let's just start with the hello world where we started. So it was this sorry, debug.print, right? This print function, if you remember, it takes two arguments. One is this array, and which we saw that we'll see what is a new weight and what is this. This is basically an array, and then it is args, which is of any type. Just now we just passed any to it, as we can see. So we can pass any type of argument to it. And but look at this. So this is basically a array of U8s, if you see. And just now, when we pass uh, hello world, and let's just keep it empty. If you see, what this will do is this will print hello world exactly as it is in the terminal, right? But we also saw that this function takes a array of U8s. So what is that? Basically, this strings are array of bytes. It's an array of bytes in set. So this string, let's just say, have something like this. So let's just say we'll define a string something using const. Let's just say hello for the hello string, and this will be something like this in quotes. So this is there. Now this hello, we'll see why it's an array of bits. So we can access each uh, since we know this is an array of like bytes that is in print function as you saw, it's an array of U8s. What this is basically if I show you, it's something like this. Uh, this hello can also be returned as hello 2, can also be returned as, we'll let it infer here. That was U8, right? Here, each character can be written as like this. This is a single character in a single quotes. Let's just say I've written it. So it can be written like this. So this hello is exactly equal to this hello. So do you see what happens? So when we pass the string to the string function, it treats it as this. And that's why it does not throw any error because it wants an array of bytes and we do provide it a string, but that string is actually stored as an array of bytes here. So now if I just do something like this, access it. So what do you think if I just want to print E instead of this? So that if both of them are same, that means I can access them as an array, which we saw earlier. So std.debug.print. Uh, Now what I'm gonna do is I'm gonna so this will be first, and this will be this second. We can use pass any to it for now. This this is gonna infer what are we capturing here from the args. Now, since this is an array of bytes, can I do something like this? Hello to just to print E, that is the second character, with index one. Can I do something like hello to one? They both should be giving me the same E, right? Because this is a string and this is an array of bytes. I do zip belt. There's no errors. And now, uh, okay. We get this 101. This is the ASCII value for it, and we don't want the ASCII value because this is stored as an array of this is stored as an array of U8s, right? And U8s are those numbers. And to print the exact character, what we are going to do is uh, instead of just passing it any, uh, let's give the proper format specifier for to print strings or any kind of characters. We have the UTF-8 encoding that encompasses a lot of the characters more than the ASCII. Although what we are seeing hello or HC, LLO are the ASCII characters, we can simply use Unicode uh, because the Unicode's initial values matches with the ASCII. Now, when we do this, you see, both of them are first is E, second is also E. So we successfully access them. So what does this tell you? So this tells you that the strings are basically in the string and Z are basically stored as an array of bytes. So it's basically a byte array, and that you can and this are equal. And now, just like the original array, right? We can do some cool mutations to it. I just say constant combine strings. So what we can do is use the concatenation to combine this. Now, this should give me hello hello to it, right? Let me just add a space to it so that it's easy to read. And what I'm gonna do this is gonna be you, and this is gonna take mine. Uh, Done. Let me just add a new line. So I'll do a quick zip build. Zip out. So yep. So do you see this? So the first character was E, the second character was this E, and we got a combined string of hello and in this method. Instead of this, let me just make this, I'll call it world. Uh, Now, once doing that, let me just change this to S to give a proper string format specifier and do this. Yeah. So that was the format specifier for Unicode. So that's why we saw an array of Unicodes. But since this is a string, we can simply concatenate it and show it as a string. But as mentioned, string are stored as an array of bytes. That's why we saw it. It's just a matter of format specifier, how you tell the compiler to show the values. But if you just change the format specifier to S, you will see this. Now that's done. You can also apply the same uh, other pattern like multiplication pattern, which we saw the star pattern, const repeat pattern. Let's just call you repeat hello, and we'll just call it like 3 times. So this is gonna be repeat pattern, and this is gonna be uh, repeat pattern. Yeah, you see the repeat pattern. Hello, 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 3 times. So that is all to it. So those are the simple basics to it. You can access it, you can add concatenations, you can repeat it. Uh, those were about, we saw about cons, we saw about variables, we saw what are the data types you unsigned. We can also use I as an integer data type. We saw about an array, like what is an array, how you declare an array in Z, how do you do some simple manipulation, which is concatenation or repeating, how you modify it. You can, we also saw what are strings. They are nothing but an array of types. And yeah, that's all. I hope you understood this. Let's see you in the another lecture.